Hello everyone, myself Sushma Visputi here to cover the next topic of data warehousing, that is OLAP operations. The objective of today's session is to understand the basics of OLAP operations and to develop an ability to use these operations to solve the real world problems. Right? So today we will cover the basics of OLAP operation. As you know, student, Inmon is the father of the data warehouse who has developed this concept, and according to the Inmon, right, the definition of data warehouse is the collection of integrated, subject-oriented, non-volatile and time-variant database. I hope you are clear with this definition, right? Already previous sessions have discussed on this detailed concept of basics of data warehouse. So data warehouse contains here the summarized data and detailed data, and this summarized data and detailed data we can use for making the decisions for the analysis and taking the decisions. So my data warehouse not only contains the detailed data but also it contains the summarized data, right? So and my data warehouse here uses the multidimensional data model, right, that is based on the aggregations, right? So in short we will cover this and we'll start with the OLAP operation in the next session, right? So here this detailed data can be input to the data mining algorithm, and data mining algorithm will give you insight and predictions based on this database that we are giving as an input to the data mining technique. And summarized data will also help your top management people for doing some analysis about their sales and business, right? So this is one example of the detailed data that we use in the data warehouse to represent the detailed data. This is the format of the detailed data that we use to store the data in the data warehouse. So why it is detailed data? Because it contains the day wise data. So total 14 days data is represented here day wise, right? So what this data says, when my day is 1, my sunny outlook, temperature is 85, humidity is 85, wind is false, my decision taken is no for playing the match by the hired people, right? Similarly, day 2 status says what? Whenever my outlook is sunny and temperature is 80, humidity is 90, wind is true, the decision taken is again no, right? So this slide shows the example of detailed data in the data warehouse. So this data you can give as a, right, this detailed data can be input to the data mining technique, and the output of the data mining technique will be these rules, right? And with the help of these rules, my decision maker can take the decisions whether to play match or not, right? So this is one example of the use of the data warehouse data, right? Now this is example of the summarized data that we stored in the data warehouse, and this summarized data uses the data cube format, right? Using OLAP we can create a multidimensional model of our data which is called as the data cube, right? For example, we can take here for the discussion the same data, that is weather data, right, which have 2 dimension, time and outlook, right? Now instead of storing this data day wise, now we have stored in the week 1 and week 2, right? So this is the example of summarized data. So summarized data always contains the aggregate operations, right? So here we have taken the summarized data for the decision whether to play match or not, right? So this summary says what? Whenever outlook is sunny here, my data is here 2-dimensional data only. So this is 2-dimensional data cube. So whenever my outlook is sunny, and in week 1 how many times the decision is taken? No, that is 2 times. 2 times the authorities have taken the decision to not to play the match, right? And in week 1 the decision is never taken to play the match, right? The summary is only for the week 1. Here similarly for the rainy outlook, right, the number of decisions taken for play the match is 2 and number of decisions taken for not to play the match is 1, right? So here which aggregate operation we have used, that is the total number of yes and no values, right? So my aggregate operation is here count operation. So number of no's are 1 here, number of yes are 2 here in the week 1, right? Similarly here in the overcast, the number of yes decisions are 2 and number of no decisions are 0. The same thing we have stored for the week 2 in the summarized format. So with the help of this summarized data also my top management people can take the decisions, right? They will get the idea about the status of the weather, right? Whenever outlook is sunny, the majority of the decision taken is no. Whenever the outlook is rainy, the majority of the decision taken is yes, because 3, right? And whenever the outlook is overcast, right, during these 14 days, 2 weeks, the majority of the decision taken is the yes only, right? So like this summarized data can also help your top management people for taking the decisions and to observe the scenario in the past, right? So here this is the simple example of the 2-dimensional data cube, right? Here I hope student you are clear with the difference between OLAP and the OLTP operations that ma'am has covered in the previous sessions, right? So here the OLAP operations are used by the knowledge workers for the function of the decision support, right? And here the database design is this subject oriented, here it is application oriented. Why it is subject oriented, that also we will discuss in detail in the next topic, right? And also it is a historical data, right? Here it is a current data. It will be summarized data and multidimensional data modeling we use to represent this data, right? Here we use the relational data modeling, right? That right? I will not talk about the DBMS here. Then here queries are ad hoc, right? Because we perform these queries for a specific subject for doing the analysis, and lots of scan is there, right? Complex queries are there. Definitely complex queries will be there because we want to find out some information, aggregate information with respect to the multiple dimensions. Here not only we are considering the 2 dimension, but we want to analyze our data with respect to the multiple dimensions, and this data will be the aggregated data, right? And so we have the complex queries here, right? And millions of records are scanned, hundreds of users will be there, because these users are less than this, because top peoples are only responsible to analyze their growth of the business, right? The data size is definitely high here because it is a historical data, past years, 5 years, 10 years data that we take for the analysis. And here the output is metric will be the query throughput. Why it is query throughput? Because it is subject oriented. For a specific subject only we want to analyze the data, so that query will be specific to the subject, that will give you some aggregated data for the analysis. And here the transaction throughput is the metric because we want to perform some transaction, day-to-day transactions here, right? For the automatic system. So in short, you can remember here OLAP is nothing but the online analytical processing, and it is a software technology which authorizes users, that is analysts, managers, executives, to gain insight into the information, right? To gain insight into the information. In short, you can remember here this OLAP technology is associated with the major tasks of the data warehouse system, and it is used for the data analysis and decision making. Now what are the uses of OLAP? We can use this OLAP system, OLAP technology, for finance and accounting analysis, right? Then for sales and marketing analysis, for production analysis, right? So total sales, total revenue generated, right? Total production in the year, average production in the year, average sales, right? Average budget, right? All these aggregate operations you can apply here, right? Use here to do the analysis in these different domains. So how your OLAP works here? So OLAP pre-calculates the most of the queries that are typically very hard to execute over tabular databases. This sentence is very important, student. If you are clear with this meaning of this sentence, definitely you will understand the OLAP operations and data warehouse concepts, right? What happens here, because my data that we stored in the data warehouse is the historical data, right? So all the aggregate values are that we stored in the data warehouse will be pre-calculated values, right? So if these values are pre-calculated, then what will happen whenever it is required by the top management people, right? Easily queries can be execute against these values to find the total sales, total revenue generated, right, in the different regions for this particular specific product, right? Then for the particular year, particular quarter, particular half an year, right? So all these aggregate values for a one quarter, for 6 months, year, for a particular product, or total for all the product, or for the one region, or for all the regions will be pre-calculated, right? And when the top management want, only simple query will be executed to get these aggregated values, right? So that's why these operations we use, right, namely aggregation, joining and grouping, right, to solve the problems, means to solve the queries here. These queries are calculated during a process that is usually called the building or processing of the OLAP cube, right? So these operations will be pre-computed here in the OLAP or data warehouse data cube. So as you know here, data warehouse is based on the multidimensional data model, which views data in the form of data cube, right? Here we will discuss the sales information. Now sales is a specific subject for the one of the company, for example manufacturing company, right? So sales data will be there that we will take for only the analysis. That's why it is the subject oriented data, right? So you know this multidimensional data is based on the two tables, dimension table and fact table. Means like your relational database system, here we store this multidimensional data in the form of dimension table and the fact table. And also student, you know what is fact table? Fact table contains actually all the foreign keys, right? Now that is primary keys of all the dimension table. Along with these foreign keys, all these keys value, it stores the aggregate measures. Those will help these top management people for the analyzing the data. For example, total dollars sold, total revenue generated, right? Total sales in the particular region, right? And total cost, right, we have gained from that sale, right? So such type of attributes are stored in the fact table. These attributes are called as the major attributes, and these, with the help of these attributes only, we can have the pre-computed values of these aggregations, and that will help for the analysis, right? And these keys in the fact table are used for linking these dimension tables. Because if you want the detailed data, this detailed data will be stored in the dimension table. So this detailed data about particular product region you can fetch from the item from the dimension table. By linking this fact table with the dimension table with the help of keys, right, those we are storing in the fact table. So this is the simplified example of the data cube, right, two-dimensional cube. If you compare this data cube with the relational table, right, in the relational table data are organized by the rows, right, and here in the cube data are organized by the intersection. right? So here we are considering the multiple dimensions for analyzing the data, right? The same table is represented here in the cube format, right? It is an example of the two-dimensional cube. My first dimension is the region here, and second dimension is the product, right? So here we are storing the summarized data, aggregate data. This one indicate what? For this East region, what is the total sale for this donut product, right? Total sale for the East region, in the East region for this donut product. Similarly, this is the total sale of the milk product in the East region. Total sale of the this is the total sale of both the product in the East region, right? Then here again the total sale of the donut product in the West region is 2. For the milk product it is a 4, and total sale in the West region is 6, right? So this is total of East and West region for the donut product. This is the total of milk product for East and West region, and this is the total sale for all the region and for all the product, right? So this is example of the two-dimensional cube, right? That is given you the idea about the product sales with respect to the region dimension and also the product dimension. So if your manager wants to find out the total sale of the donut in East and West region, directly my manager will fetch this value from the cube. If my manager want to find the total sale of the milk product in East and West region, directly my manager will find this value from the cube. No need to execute the runtime query, right? If you execute the runtime query, you need to write out the group by query here with the help of aggregate function. Then that will be definitely complex query. Now we are consider here only two dimension, but in real practical there will be hundreds of dimension for the analysis, so it will be really very complex query, and that's why these values will be pre-computed in the cube, right? So directly these values, pre-computed values, will be fetched by the manager people for doing the analysis, right? So this total will again say the 10 is the total sale for all the product and all the regions. So again this will be the value stored in the data cube. As per requirement, my manager people can fetch this value. Again this value, if they require for only East region, they can fetch here. Only for West region they can fetch from here, right? For each and every cell there will be associated one group by query with the aggregate function. I hope student you are clear with this multidimensional data modeling, how data is represented in the summarized data is represented in the data cube here. So here another example of the multidimensional data modeling. This is two-dimensional data modeling that we discussed in the previous slide, and this is the example of the three-dimensional data. So as we discussed in the previous slide, here the summarized data will be stored in with respect to the three dimension. Here one of the dimension is my time, that is quarter, means quarter 1 from January, February, March, for example, quarter 2, April, May, June, and so on, right? And here product, with respect to different product we can do the analysis, and with respect to different region. So this value will contain here the total sales of product 123, right, for region 1, right, for region 1 and for all the quarters. This cell will contain the total sales of product 1 to 23 in the region 2 for the year, right? Similarly here this particular cell will contain the total sale in only quarter 2 for all the product, and which region? Here that is region 1. This particular value will contain the total sale of all the product in region 1 for the quarter 1 only, right, and so on. I hope you are clear with this. This data cube will have the summarized data like this, right? So same thing is represented here for the sales volume. So as we say that my data warehouse contains the subject oriented data, my subject is only sales here. Like your college system, we have the different data, that is for placement data, library data, academic performance data. So placement will be one subject, right? Academic will be another subject, then your library will be another subject. So there will be one cube, right, for one subject. So if you want to analyze the placement data, you will design one cube for the placement analysis. If you want to analyze the placement data, will have all the aggregated data, number of student place in year wise, right? In the different companies, company wise, instead of product you can take here company. Here instead of region you can take here the, for example, year, right? And instead of month here you can take the, for example, class, right? So class wise, right, then company wise, and here yearly or semester wise you can do the analysis of number of student place in that particular company, or for all the company, or for the for the A division only, for B division only, right? Or for the particular year, or for particular company, right? You can do the analysis. Means all the aggregated data related to the placement will be stored in the one cube. So for every subject there will be one cube in my data warehouse. So similarly, if you want to analyze the database for the library, then there will be separate queue for analyzing the library data. That queue will store the summarized details about the library books. So total usage of a particular use, right? Which student have used this usage, so class wise, subject wise, right? All you can decide your dimension as per your application requirement, and you can do the analysis, or you can have the summarized data in your cube, right? So same thing is represented here. So as we discuss here, this cell will have, this particular cell will have the total sale of VCR product in quarter 1, right? In which country? That is USA country, right? Similarly, the next below sale of this VCR will contain the Canada, for summarized value for the Canada, then next will contain the Mexico, and so on. Similarly, here this sale will contain the total sale of the TV project, right? TV product for the USA country only, but for all the quarters. Here again this cell will contain, right, the total sale of PC for the USA only, for all the quarters, means for yearly sale, for annual sale, right? Then this will contain the annual sale of the VCR for the in the USA country, and so on. Similarly, this will contain the sum of all the quarters, means annual sale of all the product in the USA. This sale will contain the annual sale of all the product in the USA country. This cell will contain the annual sale of all the product in the Canada, and so on. And this will contain all the summarized data for all the product, for all the quarters, and for all the country, right? This total, like our 2D dimensional we discuss here. So this cube will have the summarized data that you can take for the analysis. Hope you are clear with this. So whatever cube we discussed in the previous slide is a graphical representation of the your data, multidimensional data, right? Now how you will put this data into the tables, right? So this cube as it is we can't take for the implementation, right? So definitely there will be some structure that is used by the multidimensional data modeling, and this structure is nothing but the fact table and dimension table, right? So this fact table actually, right, represents your data cube, right? That graphical representation is nothing but the representation of this fact table, but instead of keys for the understanding we have taken the name of the product, then name of the country and name of the quarter, but actually these contain only the IDs, right? IDs of these products and their country IDs and the time ID, right? So that data cube is nothing but the representation of the fact table. So this fact table is nothing but my data cube, which will have these dimension keys of this dimension table along with these aggregate values. So not only single value, aggregate value you can store in the sales of the cube, but also it can have multiple values, right? For example, units sold, number of units sold in the year, in the region, right, or in the quarter, then total dollars sold means total income from that sold, right, year wise, product wise, right, average sales, right? So these are values will be pre-computed with the help of complex queries, right? I hope students you are clear with this. So whenever you need the detailed data, you can use the join operations, right, to fetch the name of these branches. For example, here name of the location, item names, right? That time you need the join operation, right? But for the understanding we have shown directly this name on the cube. So lot of OLAP operations are available here that we can use to retrieve this data with the different views or perspectives that we will cover in the next topic. Thank you.